Welcome to the demo for the project for CipherCop Hackathon, presented by Telangana Cybersecurity Bureau, Bureau of Police Research and Development, and Indian School of Business. I am Chirayu with my three team members, Chandralekha, Vishnu, and Krishnan. In this hackathon, our objective is to implement artificial intelligence and machine learning to detect fraudulent websites. Our project our project name is Spot the Fake. As the name suggests, that our project is supposed to detect, identify, and mark any website which is given to the model. It should be able to understand the structure, it should be able to understand the metadata, it should be able to understand the digital content that is available on the site. As we are very aware that technology is evolving, as digital adoption grows, online are also growing parallelly. Fake websites mimicking banks, e-commerce platforms, and popular services are designed to steal sensitive data. Traditional detection methods are reactive, but they are not relying too much with the modernization of generative AI and how intelligence is becoming a part of our daily life. So there is a strong need for proactive AI powered system that can understand, that can detect and should be able to flag the suspicious websites which are gathering the user's data. In this project, we have three major objectives we have tried to achieve. The first one is to detect suspicious language in websites and digital content using natural language processing. Our second major objective is to compare user interface similarity using computer vision, which is a very promising technology nowadays to identify different digital content to where the sites are cloning or not. Our third major objective is to risk classification of websites, whether the website is legitimate, is it suspicious, or is it a phishing website using the website's metadata. Let's talk about the very first problem that which is the natural language processing based classification. So what we had tried to solve in this problem, that we had taken the website's data which was already available on the Kaggle. We took the data, we parsed the data from HTML to text. Then the parsed data, we passed it to the Gemini model, which is a pre-trained model and which is very efficient to identify whether the content that is present in the HTML is a phishing data or not. And then the model is trying to understand the structure of the HTML, understand the words, understand the JavaScript scripts which are implemented. Are there any redirections or are there any external features which are not supposed to be in there in a legitimate website? So our approach to this is that, as I suggested, so this is a JSON structure that you are seeing on the screen that we created, and these are the indicators that the model has given to us. Before now, I would I would like to hand over this meeting to the Chandralekha. Chandralekha, please turn on your mic and explain our
Yes,
users to that how we have approached, and she will show you the exact implementation how we did it. Please
yeah,
share
hi,
your screen
Chirag.
and continue. Hi.
Yeah, okay, I'm sharing my screen. Hope it is visible. Firstly, I would like to start with showing the data set that we used in Kaggle. This is the phishing website HTML classification, under which we have a couple of folders. This fish folder consists of around 4,000 odd files, which are all HTML files and are marked as phishing websites already. And similarly, we also have data for not fish. I'll quickly walk you through the folder structure and what we actually did here. The initial step was to get the HTML data from fish as well as non-fish folders. Major challenge that we had is we did not have any metadata related to this HTML. All we had is the content or the URLs or the headings mentioned in the HTML tags. The route we chose is to load the HTML data And then we developed a structured prompt here, if you can see, wherein we passed a fixed JSON structure containing certain phishing indicators and legitimate indicators like brand impersonation or verifiable details, etc. And we use Gemini 2.5 Pro model, as Chirayu initially mentioned. We passed all the HTML data. We initially cleaned it and passed all of it to Gemini 2.5 Pro model, and we expected it to return us a data in this format and also indicate if the summary judgment is a fish or not fish. But one limitation which we had was the daily limit, which is around 100 hits to the Gemini 2.5 Pro. We only were able to collect little data. Even though we had large data set, we could not prompt everything and get data for everything. With whatever data we collected, I'll quickly show how it looks. So this is how the Gemini had returned a JSON output with summary judgment as fish. And if we see here, the original category is also fish, and it returned a confidence score and certain indicators like brand impersonation and what is its status and sensitive info request, etc. We have all these details. Once this data set is ready, next step that we did is to just go and extract the data into several features and train a random forest classifier to see if the new test data that we are going to give is going to be classified as phishing or non-fish websites. This entire script is to just train the model. The next most important step that I would like to show is how did we validate if our model is performing well or not. I have curated few test cases which you see here on screen. The first one says that it is a fish. That is what we curated the test case for. Let's see what our model returns. I'm just running this validation script. If we look at the row 0, which is the first test case, it says that the true summary is fish. If we manually read it as well, I gave suspicious URL scripts as true, then sensitive info request true, brand impersonation true. Manual judgment also says that this test case is a phishing website. Similarly, our model also returned the same. And these are the probabilities which you see here. Probability of phishing is 0.89, which is way higher than the non-phishing value. Hence, we assigned it a label of fish. Similarly, we have written more test cases, and these are its relevant outputs. Okay. Yeah,
Great.
Chirag.
Great, Chandralekha. That is really amazing that our first approach towards the natural language processing part was to use the predefined model, then create our own data set, then create our own machine learning model that should be able to identify the new websites coming in. Amazing. But to our viewers, is this the end, or is there any scope that we can move forward? There is The answer is definitely yes. We are not stopped with just natural language processing. The another approach that I would like to draw attention of our viewers is the risk classification, which is for this part I would like to introduce my friend Vishnu. He'll come and explain that what are the approaches that we used in this. So now we need to understand before I hand over mic to Vishnu, which is, Are is AI advanced till now that we can directly use it? No, it is not. It is definitely not. We still need some rule-based systems to identify, understanding the continuous pattern changes on the websites. Vishnu, please take over from here, and I would love to hear from you that what you have done on this part.
Sure. Thanks, Ayu. So I'll be sharing my screen now. So as Chirayu has already mentioned, we have already used ML for NLP and computer vision for AI. So we also decided to go with the traditional approach based on the historical data that we have and the past websites and all the research, the research that's already been done before. So what I did in my case with the decision tree. In case of risk classification, I've used the decision tree model, where we have gone through a few of the past research papers, and based on the filters with which they have identified before, we have used some of them which we feel are useful in our cases to help with the NLP as well as with the computer vision. So based on that, what we have done in our cases, we have put the indicators into three different types. So sorry, we have classified them into three different types with two different indicators. So one of them is strong phishing indicators, and other is a weak phishing indicators. So based on how many strong and how many weak indicators each URL is triggering, we are deciding whether to go with the whether it's a phishing website, whether we classify it as suspicious, or whether it's a legitimate website. So for this, most of the data that we have gotten is from the Whois website, where we get the metadata of each URL which is provided. So other than that, we've also used the URL, the length of the URL, the characters which are there inside the URL, and the DNS related values inside it. We've also gone to the URL to check if the URL is active or not, as a lot of suspicious and like phishing URLs are generally active for a short period of time, and uh, then they go offline. So I'll just take you through what all are the features that we have used for this, starting with the hard phishing rules. So one of the most common things we have used is in this is we have observed in the phishing websites is that we have at the rate symbol, which is very commonly used in phishing websites, because anything before the at the rate is completely ignored. And in a similar way, when we are trying to get the data from Whois website, if there is no DNS record which is present in that, that also indicates there's a high probability that the website is a phishing website. Other than that, we have also taken the domain registration time, how long the domain has been active, and a few other features uh, relating to the domain metadata, which helps us identify if it's a genuine website or not. So most genuine websites have a longer domain expiry time, as well as a longer domain runtime as well. So other than that, we have taken a few weak indicators also. So weak are suspicious ones, which we do not directly want to classify them as phishing, but still there is a good chance that they might end up at phishing as a phishing website. So for these, we have taken, as you can see here, we have taken a few more the dash, sorry, few more indicators over here. These are the weak symbol indicators that we have taken. Uh, Few of the major ones where we have seen suspicious activity happening is when you have the hyphen symbol in the domain, and like few other question marks, logins are required, IDs are required. These are a lot of cases which we have observed in the domain name, especially these characters are present, they lead to the weak signals. So weak signals, what we have done is we have not directly gone if it's a weak signal, we haven't categorized it as a suspicious website. Instead, if it is triggering more than one weak signal, then we are classifying the website as a uh, suspicious website. So the highest priority is first classifying all the ones which we are guaranteed to get as phishing websites, and then in the remaining websites we decide whether a website is a suspicious website or a genuine website. So I'll just run the code and I'll show you how the output is. So these are few of the test URLs that we have taken. So Google, Facebook, and there are a couple of phishing websites also we have included in this. So based on that, I'll run the code now, and you can see the output how it comes. So first we've gone to Google. So because Google, the domain age, also while printing all these values, we've also printed the domain age, the months to expiry, and the reason why any website has been flagged as either suspicious or as a phishing website. So as you can see in this case, Google is a legitimate website, so you have no issues with that. You have a very long domain age, which is around 20 years. And then Facebook is another one, which is a legitimate website, which is classified here. And then we go to the suspicious websites. So this is one of the suspicious websites, and it has been categorized as suspicious because when we try to reach it, there has been no response from the website, and it's either unreachable or dead. This is a very common tendency in a lot of phishing websites, which is there. So similarly, this is one more website which we have tried on, and because it's unreachable or dead, it has also been classified as a phishing website. For the next one, which we are seeing here, this website has a domain expiry in 0 months. So basically, there is no domain active right now for the website. It's completely missing altogether. So this is directly a case in which it's almost like 100% a phishing website that's been just been used for a short while to fish customers in, and then once it's done, they just close down the website completely. Same with this case. And the last one, we've again tested it out with YouTube, which is again a legitimate website. And as you can see, most of these websites with very short domain ages are classified as uh, classified as phishing websites. Other than that, we have also taken the server which is hosting the website also. So generally, most of the phishing websites are based on free servers, whereas the genuine websites are generally based on paid servers. So that is also one of the categorizing features that we have taken into uh, classify them into whether they are legitimate or a phishing website. So now I'll again pass it back to Chirayu, who will continue and explain with the next
Thank you.
feature that
Thank
we
you
have
so
used.
much, Vishnu. Amazing, a very amazing approach. I would like to draw attention of our viewers to a very important point here, that our team has not been limited to the only part of the content of the website, but we have taken a step forward to understand the networking part also. We have tried to understand our model, our rule-based system is try to understand the networking, the server, and what kind of entity is present on the domain name itself. This is then another step down, a much deeper approach to go. Uh, Another question rises here, that is this enough only? Is natural language processing or understanding the networking part of a website or understanding a server is enough? Definitely, you know the answer. It is not. It is definitely not. Then what things need to be added? So here comes our third approach, which is computer vision approach. On this approach, our team member Krishnan and I, we have both worked together on this. This approach has two parts. The first part is the logo detection, where we have tried to understand how a logo of a website, how the favicon icon that we are very familiar with the website name, that how does it, uh, how does the logo similarity and dissimilarity works in computer vision. Our next approach in the same domain is the UI element similarity. The understanding the logo is not enough. There are so much different UI materials that is available, which is tricking our population, our people of India, that needs to be understand by a machine learning or an artificial intelligence model. I would like to invite my friend Krishnan. Please share your screen and please share at first point. We would like to see the data that we have used for the logo prediction.
Hello, Chirayu. Thank you for I, I, inviting me on the call. So yeah, so we went with the website and uh, web website which gives the logo in Kaggle, and then we used
Krishnan, just
the
a sec.
logos.
Could you please share your screen? We are unable to see your screen.
Okay, yeah, just a minute. Okay, so for the logos, we got the images from Kaggle. This this data has close to 1,400 logos, and then we trained the model in such a way that uh, the logos that belong to the same brand are close to each other, and the logos that belong to different brands are far, far away from each other. And uh, yeah, so we have trained the model with neural networks, and then I can just show you a quick quick demo?
Amazing. It
Or
would be better if we
yeah, so
let our
let's
viewers
say
visualize it, what exactly happened. So I would
yeah,
like to
let's
conclude that
say
what we
I
did
have
in this
just
approach.
edited the
Yes,
image of Adidas, for example, and let's say I upload it, and it will say the image is very similar to Adidas, and we need to analyze the data more. Similarly, as a extension to the logo, uh, we can also go deeper and study the similarities of the website itself. It will analyze um, the elements inside the website and then give you a similarity based on that. So these are the parts that cover the computer vision.
great.
Over to
Uh,
you, Chirayu.
Great. Thank you so much, Krishnan, for explaining our third and final approach. So I would like to draw our viewers' attention. These three are individual approaches, but what we try to solve is that we are trying to build an integrated system, because single model is not enough today to identify and detect a fraudulent, a phishing, or a legitimate website. Thank you so much for being patient and be with us for this long.